Hello everyone, welcome to AP Calculus. This is 30 most important question series on area bounded by polar curves. So we are doing the question number 4. Find the area of one petal of r is equal to 4 cosine of 2 theta. So here r is equal to 4 cosine of 2 theta. So it is like this, r is equal to, you can say this is a cosine of n theta. This is a rose curve. So first let's understand how to draw this graph. So here what is the value of a? 4, which is indicating the length of the petal, and n over here is 2, which is even. So when the value of n is even, so you can say number of petals will be equal to double of it. So 4 petals will be there. Since it is the cosine curve, it will start from the x-axis. First leaf will be on the x-axis, and gap will be, what will be the gap? Total angle is 360 degree divided by the number of petals, which is 4. So each petal will be at a gap of 90 degree. So let's draw the graph. Since it is a cosine curve, so first petal will always start from the x-axis. In the sine curve, it doesn't start from the x-axis. So here the first petal will be this. The length is 4 over here. Now since the gap of 90 degree, so first one is at this, second one is at the 90 degree, third one will be at the 180 degree, and the fourth one will be at the 270 degree, like this. Now it is saying find the area of one petal, only one petal. So for that one petal, we have to find the radial lines over here, from which angle to which angle. So for the radial line, we will be putting r equals to 0. So 4 cosine of 2 theta equal to 0. So cosine of 2 theta equal to 0. Now we have to see at which angles cosine is 0. So cosine is 0 at the odd multiples of pi by 2, which means at the pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, and so on. So here theta will be, if you divide all of them by 2, it's pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4, and so on. So now if you look at this, the radial lines over here, first one is pi by 4. So this line over here, this is pi by 4. When we say 3 pi by 4, this is this line, 3 pi by 4. Then the another one is 5 pi by 4. It will be this line over here, 5 pi by 4. Since we have to find the area bounded by one petal, so either you can go from 3 pi by 4 to 5 pi by 4, or since it is a symmetric curve, so this line will be minus pi by 4, or we can go from minus pi by 4 to pi by 4. You can pick any of the angle. So let's pick minus pi by 4 to pi by 4. You can pick 3 pi by 4 to 5 pi by 4. Also, it will give you the same answer. I am picking minus pi by 4 to pi by 4. So now we can say alpha is minus pi by 4, beta is plus pi by 4. Area is equal to integration from alpha to beta half r square d theta. 1 by 2 taken outside, this is minus pi by 4 to pi by 4 r square. R value is 4 cosine of 2 theta. So when you do the r square, that will become 16 cosine square of 2 theta. 16 can be taken out, it will become 8. 16 divided by 2 is 8. And now cosine square theta. Cosine square theta is 1 plus cos of 2 theta by 2. The formula which I am using over here is cosine 2 theta is 2 cos square theta minus 1. So cos square theta will be 1 plus cos 2 theta by 2, double of that angle. Now we can divide this 2 also. So 8 divided by 2 is 4. And now if you want to integrate this 1, so integration of 1 will be theta, and integration of cosine 4 theta is sine 4 theta divided by 4, and that is going from minus pi by 4 to pi by 4. So now if you put the values, if you put the upper limit pi by 4, this will be pi by 4. Now if you put the pi by 4 over here, 4 times pi by 4, that will be sin pi. Sin pi is 0. minus lower limit minus pi by 4 if you put. Again if you put the minus pi by 4 over here, so sine of minus pi, that is also 0. So finally you will be getting pi by 4 and this plus pi by 4. So that will be pi by 2 and multiply by this, that will be 2 pi. So final answer will be 2 pi square unit. That is the area bounded by the one petal. If you want to find the total area, that will be 2 pi times 4, that will be 8 pi. So I hope you have understood the solution. So if you have any other doubt related to the AP calculus, you can send your doubt over this particular mail ID. Thank you for watching.